Is a file system just the layout of folders? I have used Windows since childhood, and when I hear the phrase Windows file system I think of directories, folders, within directories, a folder called system, a folder called program files, etc. Is this what the system is? Just the layout of the folders? And then I recently started using Linux, and my reference book says in the Linux file system everything starts at root and branches off from there. How is that really different from Windows? I mean, it seems the Linux system and the Windows system are just two ways of setting up a directory tree. Is this what file system means?
Just the layout of the folders.
Sounds too good to be true. Let's take the FAT32 file system as an example.
I can install Windows XP on it, but I can also use it on a memory card.
On a memory card, you don't have those folders that you sum up. So,
don't confuse the directory layout of a family of operating systems with a file system. Is this what a file system means? No. It refers to the underlying bits and bytes that make your directory structure work.
The underlying bits and bytes?
Show me FAT32.
Let's look at what FAT32 looks like. It has
some header sectors in the beginning, like volume1.d, and reserved sectors. 2 file allocation tables, allowing us to figure out where our files are. Clusters containing all our directory and file data.
Some very small unused space that we can't use.
A FAT table consists of a lot of entries that look like this, allowing us to determine where the directory or file is stored in the cluster space, as well as some attributes and size.
A directory entry would point to a list of directory/file entries.
In the clusters space, we can now travel our clusters to find the data we need.
A cluster essentially contains data and information where the next fragments are.
Do other file systems differ? Show me NTFS. I'm going to show you an image so you can notice the differences. The rest is homework for the reader. More information can be found on this blog archive or Google. This URL.
What about the file systems on Linux? Show me x2/3.
The idea is that x2/x3 use superblocks and inodes. This allows for soft and hard links, directories that are files, files with multiple names and so on. The main gist is abstracting a way to allow the file system to be capable of doing more meta-ish stuff. This URL.
The big difference between Linux and Windows, at least when it comes to their file systems and directory trees, is that in Linux everything is a file, and everything descends from a single root. This also applies to almost all Unix-derived OSs such as BSD, OS X, Solaris, etc., but I'm going to just say Linux to be generic, if not entirely accurate. But what does that mean in practice? Windows allows for multiple named roots for their file systems. You understand these as drive letters, C column, D column, E column, and so on. Each one has a root, backslash, and a tree that descends from it. Recent versions of Windows allow for things like volume mount points, where a volume, what you'd consider a partition, can be mounted to an existing, empty folder. So instead of the column, representing the root of, say, your optical CD/DVD/BR drive, you could mount it at C column \optical instead. This is more similar to what Linux does. There's also an underlying, single-rooted, object namespace for everything in Windows similar to what Linux uses and is managed by the Object Manager, but most users rarely see it referenced since it's primarily for kernel use. Linux has a single root, /. Everything descends from it, and it doesn't necessarily need to represent your hard drive. Hard drives, optical drives, memory cards, network shares, printers, scanners, CPUs, RAM, processors, everything is represented somewhere inside this single namespace, and can be accessed by any process with standard file management APIs, presuming you have a high enough level of access. Just because you can read or write from it doesn't mean it's a file on your hard drive in Linux. For example, devices are typically mounted into /dev, so accessing things in there often means you're talking to a device. Maybe it's the sound card, or a scanner, or a camera, etc. These are known as device files. Props is a special file system that's normally mounted to /proc and has a directory for every running process, with files in each directory relating to things like the command line used to invoke that process, memory maps, open files, etc. Sys is another special file system, mounted on /sys, used to expose a wealth of information about the running kernel objects and can also be used to fine-tune the running kernel by simply writing to a particular file.
You can think of file systems as different formats for storing files and folders, somewhat analogous to how MS Word and PDF are different formats for storing documents, or MP3 and WAV are different formats for storing audio. Given a few files and folders, the file system is the format and the code that stores them to disk so they can be read back again. And just like not all video players can play all video formats, not all operating systems can read all file systems. For example, if you store a file from Linux on an X3 formatted USB stick, Windows cannot read the file since it doesn't know how to handle the X3 file system. Common file systems include FAT and NTFS, Windows. NTFS is standard on newer Windows versions. X3 and X4, Linux. HFS+, OS X. ISO 9660 and UDF, CD, DVD and Blu-ray. See Wikipedia for a comparison of file systems.
The file system is not only about how a directory tree is set up, but also how this information is encoded on the media, too. There are several file systems for Linux, X3, XFS, Razors, etc.
If you want to support the channel, please consider subscribing.